Hi, I'm Angela.
Hi, my name is Kenneth Amir Galera.
Hi, I'm Mika.
Hi, I'm Dea.
And today, we will be solving a problem in calculus regarding related rates. The problem says a man 1.5 meters tall is walking towards an 8.2 meter tall lamppost at the rate of 1.2 meter per second. Find the rate at which the length of his shadow is changing. In any problem, you can use the technique called PIES, where P stands for picture out the problem, I identify what is given, E look for the equation, and S solve for what is asked. The first thing that we're gonna do is to picture out the problem. So a man 1.5 meter tall, here's the man, is walking towards the lamp, which is 8.2 meter tall at a rate of 1.2 meter per second. Notice the word towards. Now, if this is the man and this is the lamp, let's take x as the distance between the man and the lamp, and s as the distance of his shadow. If the man is walking towards the lamp, then the shadow of the man must be decreasing. Therefore, dx over dt will be equal to negative 1.2 meter per second. Next, the problem is looking for the rate at which the length of his shadow is changing, or simply ds over dt.
Now, we have pictured out the problem and identified what are the given. Let's now find an equation that would suit what is required. In our problem, we're going to use similar triangles. Notice that this bigger triangle right here is proportional to the smaller one right here. If we're going to look at them one by one, these triangles are both right triangles. Also, they have the same theta. To find an equation, let's find any trigonometric function of the triangles and equate it, since we have similar triangles. So the tangent theta of this bigger triangle will be equal to opposite over adjacent, or simply equal to 8.2 over x plus s. Meanwhile, the tangent theta of the smaller triangle is equal to still opposite over adjacent, therefore it's equal to 1.5 over s. Thus, the equation will now be 8.2 over x plus s is equal to 1.5 over s.
The next thing that we're going to do is to simplify the equation. So, we are going to cross multiply this 8.2 times s and 1.5 times x plus x. Therefore, 8.2s will be equal to 1.5 times the quantity x plus s. So, just simply distribute the quantity x plus s. So, it is going to be 8.2s is equals to 1.5x plus 1.5s. So, now, we're just going to subtract 1.5s to both sides. So, 8.2 minus 1.5s will be just equal to 6.7s equals 1.5x.
Since we now have a simplified equation, the next thing that we are going to do is to solve for what is required. But before that, we must first take the derivative with respect to time of both sides of our equation. So here we have 6.7 times ds over dt is equal to 1.5 times dx over dt. Notice that what we are looking for is ds over dt, and we already have a value for dx over dt. So what we can do is to substitute and solve for what is required. Thus, 6.7 times ds over dt equals 1.5 times dx over dt, which is negative 1.2 meters per second. So ds over dt is equal to 1.5 times negative 1.2 meters per second over 6.7. Now, ds over dt is equal to negative 0.27 meters per second. Thus, the rate at which the length of his shadow is changing and is decreasing by 0.27 meters per second. So that's it. That's the solution.